In this video, we're going to learn the properties of the expectation and the variance of the sum of discrete random variables. In fact, for any discrete random variables x and y, it is true that the expectation of x plus y is equal to the expectation of x plus the expectation of y. And the variance of x plus y is equal to the variance of x plus the variance of y plus 2 times the expectation of xy minus the expectation of x times the expectation of y. Furthermore, if x and y are independent random variables, that means the probability distributions of x and y will not affect each other. Then the variance of x plus y is simply equal to the variance of x plus the variance of y. Let's take a look at the proof of these results. Suppose the possible values of x are x1, x2 to xm, and those of y are y1, y2 to yn. We let ai be the event that x is equal to xi and bj be the event that y is equal to yj. Then by definition, the expectation of x plus y is equal to the sum of all the possible combinations of x plus y times the probability of a and b. This expression can be written as a double summation like this. Here we can expand this bracket of x plus y, and then distribute the first summation sign like this. For xi, it is actually a constant for this summation sign with j as the index. So we can take out this constant xi from the summation sign like this. For the summation of probabilities here, by the law of total probability, it is simply equal to the probability of ai. Now we can distribute the second summation sign like this. For these two summation signs, we can interchange them, because this will just affect the order of the summation of terms, but the order of summation will not affect the final sum. In this way, yj is then a constant for this summation sign with I as the index. So we can take out yj like this. Similarly, for this summation of probabilities, by the law of total probability, it is just equal to the probability of bj. As a result, we can end up with two summation expressions here, and they are actually equal to the expectation of x and the expectation of y respectively. This is how we can prove that the expectation of x plus y is equal to the expectation of x plus the expectation of y for any discrete random variables x and y. Now for the variance of x plus y, we can consider it as the expectation of x plus y squared minus the square of the expectation of x plus y. As we have just proved that the expectation of x plus y is equal to the expectation of x plus the expectation of y for any x and y, this expression can then be expanded in this way. After rearranging the terms, we can get that the variance of x plus y is equal to the variance of x plus the variance of y plus 2 times the expectation of xy minus the expectation of x times the expectation of y. And this result is true for any discrete random variables x and y. Suppose we are further given that x and y are independent. By the multiplication law of probability, we have the probability of ai and bj is equal to the probability of ai times the probability of bj for any I and j. In this way, we can easily get that the expectation of xy is simply equal to the expectation of x times the expectation of y. As a result, the expression here is equal to 0. And thus the variance of x plus y is equal to the variance of x plus the variance of y if x and y are independent. This is how we can prove these results. With these results, we can easily deduce the properties of the expectation and the variance of the sum of 3 or more random variables like this. This is how we can handle the expectation and the variance of the sum of discrete random variables.